Hi students, now we are going to discuss the effect of dielectric in a capacitor. So for this first case 1, when capacitor is disconnected from the battery. Another case is when the capacitor is connected to the battery. So now we are going to discuss the first case. That is, a parallel plate capacitor is connected to a battery of potential difference V0 volt. So the capacitor is charged to a potential difference of V0 and the quantity of charge stored in the plates of the capacitor is Q0. The uniform electric field between the two plates without a dielectric. Without a dielectric means, let us say, air of permittivity epsilon naught. So the electric field is denoted with the symbol E0. So the first picture is with the battery. First one is with the battery. So after charging this capacitor to its maximum quantity Q0, we are going to disconnect the battery. Okay. Now you see here, in this case, the quantity of charge is Q0, the potential difference is V0. Therefore, capacitance is denoted by, okay, the capacitance is denoted by C0. Okay, C0 is equal to Q0 divided by V0. So this is equation 1. This is a normal expression for the capacitance. The capacitance is the ratio of the quantity of charge to the potential difference. Okay, students, this have you all understood? Okay. Now what I am going to do is, I am going to disconnect this battery. Okay, I am going to disconnect this battery, and you see that in the second picture there is no battery here. Okay, there is no battery. And in the second picture, you can see one dielectric is also present between the two plates. One dielectric slab is introduced into the space between the two plates. Now, whenever a dielectric is introduced between the charged capacitor, what will happen? The electric field, external electric field gets reduced. See, we have already studied this concept, is it not? Suppose if these are the plates, positive and negative, there is an electric field in the downward direction. This is the external electric field. Suppose if a dielectric slab is introduced, means what will happen? Dielectric polarization will happen. We have studied or not? Dielectric polarization means what? There will be induced charges on the both faces of the dielectric slab. So suppose here there is a negative potential for this plate of the capacitor, means then here positive induced charges. These are induced charges. And here towards the positive plate negative charges. So you can see inside the dielectric slab an electric field is established in the opposite direction. Is it not E dash, say for example E dash. Okay. And this is E external is denoted by what? E0. So the external electric field is in the downward direction, and the electric field which is induced inside the dielectric slab is in the upward direction. So what is the net electric field? The net electric field is equal to what? E0 minus E dash. Is it not? That is why it is less than E0. It is less than E0. This concept is a separate topic we have studied in the regular class. So you keep it in your mind. What happens to the electric field when we introduce a dielectric? It gets decreased. Is it not? The electric field decreases. It depends upon by how much it will decrease. It depends upon the dielectric constant epsilon r of the dielectric. You see here epsilon r. Okay, students. So after removing the battery and introducing the dielectric, the new electric field will be lesser than the original electric field. So let us denote this by the symbol E. Okay, this new electric field will be the old original electric field divided by epsilon r. So this is another equation. This is important for us. Okay, this is based on the previous concept we have derived. Okay, students, now what will be the new potential difference then? The new potential difference is denoted by the symbol V. So this is equal to E into the distance of separation between the two plates. So E into D. So I am going to substitute this. E is equal to E naught, okay, divided by epsilon R into D, okay. But E naught into D, here this E naught into D is also equal to what? E naught into the distance of separation D between the two plates, okay. E naught into D is equal to V naught, okay. So instead of E naught into D, I am going to substitute V naught. Therefore, what is V is now equal to V naught divided by epsilon R. So this is another equation number 3. Have you understood? So from these two equations, we find that after introducing the dielectric, the electric field decreases. Similarly, the potential difference also decreases. Once again, in the summary, I will tell you. Okay. Now, what will be the new capacitance? Let us find out. So, new capacitance. The new capacitance, let us say C. I will take the symbol C. So, this C is equal to Q naught, the original quantity of charge. Once we have removed the battery, means you must all remember that the charges initially stored in the capacitor is not going to change, because we have stored some charges Q naught by using the battery. Then the battery is removed, the charges does not get reduced, the charges does not increase also. So Q naught remains constant in both the cases. Q naught will be the same, but the potential difference is changing. Therefore, now the new capacitance is equal to the original quantity of charge divided by the new potential difference, by the new potential difference, that is V. So this is equal to Q naught divided by the new potential difference. V is equal to what? V naught divided by epsilon R. So in the denominator it is V naught divided by epsilon R. So rewriting this, C is now equal to epsilon R times Q naught by V naught, or C is now equal to epsilon R times C naught. See here, this is another important equation. So this is equation number 4. So the first equation is C naught is equal to Q naught by V naught. This is the original capacitance when the battery was connected, okay. Then now you can see after the battery is removed, the charges stored in the capacitor is not going to change. Therefore, the numerator Q naught. But the potential difference in the absence of battery is V. Therefore, denominator is V. So we have got an expression C equal to epsilon R into C naught. Okay, students. Now, what will be the energy? Okay, the energy before that energy is that is before disconnecting. Energy before disconnecting, I will take this is U naught. Okay, U naught. Now energy is equal to what? Half into Q naught square divided by C naught. Energy before disconnecting, let us say it is denoted by the symbol U naught. So this is equal to half into Q naught square by C naught. Now after disconnecting, okay, so new energy, what is the expression for the new energy? Let us see. So this is denoted by U, let us take. So the new energy must be equal to U equal to half into the charges before disconnecting and after disconnecting, the battery will be the same, is it not? Therefore this Q naught square will remain there in the numerator, Q naught square divided by, in the denominator in place of C naught I have to substitute what is C. So this is equal to 1 by 2 into Q naught square divided by, instead of C I am going to substitute what? Epsilon R into C naught. And this 1 by 2 into Q naught square by C naught is nothing but U naught. So we find that the new energy U is equal to U naught divided by epsilon R. So this is equation 5. All are related terms only. All these are related only. Have you understood? So now we are going to write the summary of all these equations. Okay. Now after the removal of the battery, can you look at the equation 2 and understand that the electric field, new electric field is original electric field divided by epsilon r. So what happens to electric field? Does it increase or decrease? Means the electric field decreases. So I am going to summarize here. So after removing the battery and introducing a dielectric, first you see that, my dear students, so Q naught is constant, the charge remains constant. Then the electric field, okay, electric field decreases, and the potential difference also decreases. So original electric field by epsilon r and original potential difference divided by epsilon r. Then what happens to the capacitance? It increases by a factor epsilon r. So the capacitance C increases. And what happens to the energy? You see, it is divided by epsilon r. So the energy U also decreases. So these 5 factors you will have to make a tabular column and remember for competitive exams like NEET and JEE. Okay students, so will you remember that when a capacitor is initially charged to Q naught coulomb and then the battery is removed, after that when a dielectric is introduced, what are all the changes taking place? You see, first Q naught remains constant and the electric field decreases and the potential difference also decreases, while the capacitance increases and the energy decreases. Okay, have you understood?